So, if you've ever tried to work with strings in GameMaker, you probably know that if you have two strings, I'm gonna say string 1 is gonna equal my very earnest mother, and var string 2 is gonna equal just served us 9. You probably know that you can combine those two strings. You can add them together, or in the to use the proper word for it, concatenate them. Let's say string 3 is going to equal string underscore 1 plus string underscore 2. You can combine strings using the plus operator. Right, that's pretty simple. And you can, if you want to see the result of that, show message string 3. And this is going to show us my very earnest mother just served us 9. Right? Okay, that's string concatenation in GameMaker. I do not know what key on my keyboard I hit there, but I don't think it was the one I was looking for. However, if you've tried to concatenate either very long strings with thousands and thousands of characters in them, or if you just tried to do a lot of this, you probably have realized at some point that string concatenation can be very, very slow. So if I were to use my old get timer trick, and for those of you who don't know, this is just going to be timing how long it takes a particular piece of code to run. You can also use the debugger for this, but I don't really feel the need to whip out the debugger for something that's this simple. And if we were to repeat this code, actually, I'm going to formulate this a little bit differently. I'm going to call it string output, and I'm going to initialize that to an empty string, and I'm going to just say repeat 10 to start with. Let me decide how I want to format this. String output plus equals. You can also use the plus equals operator on strings in GameMaker just the way you can with numbers. Plus equals string 1 plus string 2. And then show message string output. And I'll get back to get timer in a minute. This is just going to concatenate these two strings 10 times. So if I were to look at the message box, my very earnest mother just served us 9, my very earnest mother just served us 9, on and on and on. Wow. That's 2 recordings in a row that I've done that by accident. I thought I turned off the setting on my computer that makes Windows do that whenever I like shake a window around, but I guess not. I'll have to deal with that later. So we can concatenate these strings, okay? And using the get timer trick, we can compare the amount of time. We can compare the system time when the code finishes running versus the system time when the game at least the section of code that we're timing starts running. So I can say var t end is get timer again, and I can show message how long this is going to take by saying t end minus t start. This is going to be in microseconds, so it's going to be in millionths of a second, which is not very useful. So I'm going to divide that by 1,000 to turn it into milliseconds or thousandths of a second. And we can look at how long this takes. This takes 0.03 milliseconds, which is pretty fast. We can also look at how well this is going to scale. So logically, if I were to do this 10 times more, if I were to do this 100 times instead of 10, we should expect the string concatenation to take 0.3 milliseconds instead of 0.03. Because we're doing 10 times as many operations, we would expect it to take 10 times longer. And we are going to see that that is actually not the case. Instead, we are taking 0.18 milliseconds. Not too terrible. Let's see what happens if I add another 0. So this is going to be 1,000 iterations of this, and we are going to be concatenating these strings 1,000 times. Okay, we've got 10.71 milliseconds. I should probably be writing these down. Let's see. Let me write down the first one in a comment or something. This is 0.06. Was 10 iterations was 0.06 milliseconds. 1,000 was, I've already forgotten. I want to say it was 10.7 milliseconds. What was 100? It's not going to produce the exact same result every time, but it should probably be pretty close. 0.16. All right. So 100 iterations was 0.16 ms. So it starts out growing pretty well, but then at 1,000 iterations, it just the amount of time it takes to do this operation sort of takes off, multiplying the number of iterations we're doing here by 10. seemingly made the amount of time it takes to do this operation go up by a factor of 100, or at least 60 or so, compared to a relatively small increase that we saw earlier. If I were to ratchet this up once again, let's do 10,000 iterations this time. We are going to be waiting a moment for the game to start, and then we can see that the 10,000 iteration version took 754.6. I'm just gonna abbreviate that at 754 milliseconds. That's about a factor of 75 or so for those doing the math. And if I were to add another 0, this is 100,000 iterations of this loop. We're gonna be shall we say, we're gonna be sitting here for a little while. So I'm going to run the game, and I'm going to just, instead of making you sit through this, I'm gonna bring up my Windows clock, and you can see how long it's going to take. I promise I won't like cheat by editing the video to make it look like it's taking longer than it actually is or something. Okay, that took, if I'm looking at this correctly, 122 seconds, 837 milliseconds. All right, that was a bit of a wait. 1000, 100,000 iterations. It's going to be 122. Let's convert that to minutes and seconds, just so that we can appreciate the scale of how long that took. That's pretty slow. The reason that this operation scales so badly, that the runtime analysis is so high, it's approximately big O of n squared. If you're into runtime analysis, is that when you concatenate strings, GameMaker can't simply append stuff to the end of the original string. When you say string output plus equals string 1 plus string 2, GameMaker can't simply append the contents of these strings to the end of string output in memory, because strings are character arrays in GameMaker. They're Unicode character arrays, and they must be continuous in memory. They can't be broken up. If you have something else in memory, there has to be space in memory for the strings. And to ensure that that is the case, GameMaker will, if it has to, it will reallocate memory for the original string plus whatever is being concatenated to it. It will copy the contents of the original string to the new location, and it will copy the contents of the strings that you're concatenating to it to the new location. That means that instead of allocating memory for the character arrays that are the new strings, GameMaker is also allocating memory for the original string as well. At the beginning, when your strings are small, it does not take a long time to do that, and GameMaker can do it pretty quickly, less than a millisecond to do it 100 times. As you add more and more iterations, you have to copy longer and longer strings to their new locations in memory, and that can scale very, very badly indeed. So there is a way around this. Some programming languages have what is known as a string builder class, or something similar. These are classes or functions or other such systems in other programming languages that allow you to get around this issue that you have with strings when you concatenate them. And in GameMaker, we don't have any such thing, but we can do something similar. We can use buffers. I'm going to call a variable, how about string buffer? That is going to be equal to buffer create. I'll initialize its size to, say, 1,000 or so. The buffer type is going to be buffer grow, and the alignment is going to be 1. Once we're finished, we must, as always, buffer delete the string buffer just so that it's not sitting there in memory. And now, inside the repeat loop, instead of, and I'm going to cut this down to, I'm going to cut this down to 10 first, just so that we start out with something a little bit easier. We can say buffer write. We can go into string underscore buffer. The type can be buffer text. It's important that you make this buffer text and not the more commonly used buffer string. We're going to be going with buffer text. And the value can be string 1 plus string 2. If you want to, you can do these separately. You can buffer write string 1 and then string 2. The output is going to be more or less the same. And then once you're finished, we can say var string output. Is that what it was called? I think I called it string output. It's going to be buffer read. Can be the contents of the string buffer, and the type can be buffer, once again, text. Or in this case, it can be buffer string if you want, but I'm going to be going with buffer text. If you want to see that it's working, show message string underscore output. We can stop the game and run it again. And this can show us, okay, you know what? We're trying to read from the end of the buffer. We need to buffer seek. The base can be 0. The base can be rather buffer seek start, and the offset can be 0. We need to go back to the beginning after writing in a bunch of text. Now when we do this, after a false start, we can see that we once again have the string of this little planetary mnemonic repeated 10 times, and they are concatenated together properly, the same way that they were before. The amount of time it took apparently took a lot longer than it was before, because that timing thing was taking into account the amount of time the message box was on the screen. Anyway, if I were to run this again without that, we're going to see that 10 iterations of this, concatenating these strings together 10 times, takes about the same amount of time as it did before. Let me write this down. 10 iterations is going to be 0.04 ms. This is it's not like this is 30% faster than the concatenation version. This is just much within the margin of error of how long these measurements are going to take. If we do this again, if I kill the game and do it again with 100 iterations, we can see how long this is going to take. And this is going to be 0.11. Again, slightly faster than the original version, but still reasonably close to what one might call the margin of error. Let's bump that up again. This is where things started to get interesting the last time. Let's do 1,000 iterations. And we are now at 0.75, which is noticeably less than 1,000 iterations of the original version. What was it? 0.75 ms. We can keep going. So 10,000. I have a good feeling about how long this is going to take. This took about 4.6 milliseconds. Okay. So 10,000 iterations was 4.6 milliseconds. And lastly, 100,000. If we do 100,000, I have a feeling I will not have to cut 2 minutes into the video in order to save time. And so that you're not sitting here, that took 42.5 milliseconds. So this scales much, much, much better. We're going to say 45. Was it 45 milliseconds? I want to say it was 45. Let me run that again just to make sure so that I'm not misleading anybody. Okay, that was about 50. We'll call it 50. We'll be generous and say it's a little bit slower. And it took 50 milliseconds to concatenate this 100,000 times, which, I repeat, took longer than 2 minutes the first time. So from 2 minutes down to 1/20th of a second. Maybe not something you want to be doing in the step event if you want your game to hit 60 frames per second, but it's definitely much of an improvement. So why is this? So when using buffers, specifically when you create a grow buffer, GameMaker will put stuff into the buffer, and like with strings, it will have to resize the buffer by reallocating memory to a location of memory with more space, and copying the original contents of the original buffer to the new location of memory. When you exceed the size limit of a grow buffer, but it will do it in a way that allows it to have to do that operation much less frequently. So whereas the string concatenation version of this little operation was reallocating the memory and copying it every single time, the grow buffer will only do it when it absolutely has to, and it will grow buffers will actually allocate more memory than they need when they resize. They will double in size every time instead of growing to exactly the new size that they need. That allows them to not have to do this comparatively expensive operation very often. And in fact, if you were to initialize the original buffer to a much larger size, let's make it 1,000,000 bytes instead of 1,000. So this is going to be up from a kilobyte in size to a megabyte. This may in fact actually cut down the amount of time that this operation requires even further. 10 megabyte size should be big enough for the entire string. 100,000 copies of this string should be well within 10 megabytes. This grow buffer may actually not have to resize at all, and it looks like we are about where we were the last time, so we're about 41 milliseconds. I'll write that down as well for good measure. And then at the end, when you buffer seek back to the start, that operation is functionally instantaneous. And when you read the final string out of the buffer, you're just grabbing all of the text inside of it. You do not have to resize anything. You don't have to reallocate anything. And this operation, this line of code, this function call will happen just as fast as GameMaker can read the contents of the memory from the buffer. And as a result, this is much, much faster. So, if you've never thought about this before, now it's something that you know about. Is this something that you should actually do when you're concatenating strings? Honestly, probably not. This is probably not something that's going to help you in most situations. As you saw earlier, there was not a huge difference in performance between the string builder buffer and just regular old concatenation on relatively short strings. When we were doing this just 10 times or even 100 times, there wasn't a huge difference. It only really started to kick in when we were dealing with like kilobytes and later megabytes of plain text. And in most games, when you're concatenating strings together, this is not something that's going to help in the slightest. But if you are doing something in your game that's text heavy, if you're like trying to create an encyclopedia entry or a journal entry which concatenates a lot of strings together and the player's name and the date and your party members and what items you have and that sort of thing to, for example, create a summary of your adventure, then this sort of string builder feature may help. If you're trying to do something like write a lot of text to a file, if you're trying to log a lot of text to a file, or something like that, something like a string builder like this may help. If you're trying to do something like build a JSON or an XML string using GameMaker's text functions, it may indeed be faster. It may indeed be a lot faster to write the text to a buffer before writing the text of the file. But it's something to think about at the very least. Also, I realized I never actually explained why you want buffer text instead of buffer string in these buffer writes over here at the top, and that is because buffer write and buffer text, the difference between buffer text and buffer string is that if I were to show message the output here, buffer text will simply write the characters that are in the string to the buffer without including a terminating null at the end, and the terminating null is what tells GameMaker that you have reached the end of the string. Whereas when you write a buffer string to a buffer, then that terminating null is included. So once you finish the letters, my very earnest mother, whatever, those letters will be followed by a 0. And when you try to read out the text from the buffer at the end, over here, GameMaker will read up to a terminating null, and then it will stop. And then if that terminating null is included with buffer string, then the buffer will stop reading the string after just the first string that we put into it, which is not what we want. And that is why we want buffer text. If you look inside the debugger, I suppose we can do this. If you look inside the debugger, not yet, without deleting the buffer. If you look inside the debugger when you do this, when you concatenate the strings, and I need to force quit the game because it's apparently getting stuck at the end, which is weird. You can see that all of the characters, all of the letters are inside the buffer, and there is no 0 byte at the end of each string. However, if I were to instead write the string, we would see that once we dismiss all those pop-ups, you can see that there are indeed a couple zeros at the end of every string. That's represented by like a space character of like just a dot. The debugger represents it as a period, but it's just a null byte. It's not actually a period character. You can see if you look at the raw data, you can see that there are 0 zeros after the space character and after the before the beginning of the next string. Okay. This ended up being a very long recording for a video that's probably not going to be helpful to a lot of people. I'll stop now. As always, I hope you found this subject to be interesting at the very least, even if it is not something that you find directly useful. I will remove that comment so that the buffer delete, so that we are actually deleting the buffer when we're done with it. Even if this isn't something that you find particularly useful when it comes to actually speeding up your string concatenations in GameMaker, I hope this at least gives you something to think about with regards to how GameMaker and the computer at large works internally. And who knows, that sort of information could come in handy in other ways at some point down the line. The code for this is probably not going to be a GitHub repository because this is really just a couple lines of like experimental code and some results from collecting statistics on performance. but I will have something in the video description. It might just be like a gist or a paste bin or something like that. Otherwise, I try to post about 2 GameMaker videos a week, one of these and one Let's Make a Tower Defense game or something of that nature. I don't know if I'll be finished with that series by the time I post this video. Otherwise, I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. You can hear yourself shouted out at the end, get the videos a day early, see what my future plans are. Otherwise, my name is Michael, and I will see you all later. Special thanks to Connor, Edward Holt, Emily Koyo, Halo Factory, Posho, Sindra Larson, Tusk, and Zenith for supporting these videos. If you want to see your name in the credits or hear yourself shouted out at the end, head on over to the Patreon page down in the video description to join the fun.